Okay, so we're back to our same data set that we looked at for when we were looking at estimating both sample proportions and sample means. So what we're going to start to look at today is how can we compare between two distinct populations. And essentially what we're going to be doing is looking at the differences, in this case, of sample means between two distinct populations. So just as a quick recap as to what this data is that we're looking at. So we have 35 individuals, the individuals being North Carolina high school students, and what we have is two different variables measured on those individuals. One being the main method of travel that they take to school, the other one being the time it takes for them to travel. So what we're going to do in this case is we're going to actually use the method of travel as a grouping variable to basically split this sample into smaller groups that are distinct from one another. So let me make us a visual here that I think will make that a little easier to see. So what we're looking at right here is essentially we've taken our sample of 35 and we're looking at them as three distinct samples. So we're looking at one population being the walkers, another population being the car drivers, and another population being the bus riders. And what we're comparing between each of these different populations is the travel time that it takes them to get to school. So let's add some visuals here that'll help us a little bit. I think the box plot is probably one of the better ones, and let's also look at the mean of each of these. So if I want to start this investigation out, one of the things that I would want to first start to talk about is what am I seeing visually between these three different distributions. And so what we're looking at is travel time. So what we're going to compare is what's the typical travel time. So if I'm looking at these, clearly from these distributions, the bus travel time is quite a bit higher typically than the travel time for the car riders or for the walkers. And if I look at a comparison between the walkers and the car drivers, I can see that they're relatively close to one another. Our measures of center are, in terms of the mean, are only about 4 minutes different. If we look at our medians, we got 17 and 14, so again, that's about 3 minutes different. Our boxes from our box plots are heavily overlapping, so those seem pretty similar. And if we look at the spread, the car riders have the smallest spread, walkers are a little larger of a spread than the car drivers, and then the bus riders have the largest spread. And also look, another way to show that they're significantly higher is that if we look at this, our x here are 30 minutes, that's actually an outlier. So if we're looking at our minimum without the outlier, what we're seeing is that we're really starting at 35 for the shortest bus travel time, if we're excluding that outlier, versus the maximum for each of the other two distributions is 32 and 35. And so there's not even overlap at these distributions, really. And that's a clear sign that there are differences going on between these distributions. So what we want to do is we want to look at then, are these differences significant? So the difference between the car riders and the bus riders, that's a significant difference, and it's clear just from looking at it. What's not as clear though is the difference between the car riders and the walkers significant? So it's different, but is it significant? And so what we want to do to start to look at this is we want to essentially look at a sampling distribution like what we did before, except now what our sampling distribution is going to represent is not a single population parameter, so not a mean or a proportion, but it's actually going to represent the difference between our population parameters. And so we can simulate this again using CODAP, but when we go to simulate it this time, we're going to have to use a slightly different process to be able to get at this idea that what we're looking at is really a comparison between two different population parameters. Okay, so let's start with using the same basic principles that we used before, namely what we want to do is we want to create a sampling distribution by taking random samples of our population. And so we're going to go a little larger this time. So previously we've been doing samples of size 10, and we had been taking 25 of those out. What we're going to do this time is we're actually going to take samples of size 35, because there's 35 individuals in the original sample, and we're going to draw 100 of those samples. And so in our items we have 35, and in our samples we have 100. And we're going to start fast from the beginning because we know that this is a slow process, and we're doing 100 samples now versus earlier we had only been doing 25 samples. So look at it go. Now if we think about what we're trying to construct here, in the end we're looking at differences between means. And again, what we want to do is we want to look at, is the difference between the walkers and the car drivers significant? And so we want to estimate what is that difference by creating our sampling distribution. So just like what we did before, we need to create a sample statistic for this. And so the sample statistic that we're creating is a difference between means. And so I'm just going to abbreviate that as diff sample means. And also, just like before, we have to create a formula to actually do this calculation. Our formula is a little more complicated what we were doing before, because we're looking at two means and we're finding the difference between them. So what we start off with is we're going to start off with a mean. And what we're going to start off with our mean is our travel time for the car riders. And so when I'm doing this, I have to first tell it the variable. So we're talking about travel time. But then I have to also tell it what specifically, what group I'm looking at. So remember, if I just do travel time, it's going to give me the mean of all the travel times. But I only want the mean of the car drivers in this case. And so to do that, I actually have to filter this using that method of travel variable. And so that's what I'm doing with this second bit here. And namely, I only want initially the car riders. And so this is going to give me that mean. And then what I'm going to subtract from that is I'm looking at differences, right? So I want to look at the difference now of the mean, still looking at travel time. But in this case, what I want to look at is the travel time for those students who reported traveling by walking. And so if I apply this, what I now see is those differences in those average travel times. And notice I have both positive and negative numbers. So let's start off by, again, looking at a graph of this distribution. So here's my difference of sample means distribution. And again, remember that what we're looking at is our car drivers, our average times, subtracted from that are walking. And so if I look at a single value here, for example, this one has a difference of 17.1, negative 17.1. What that means is that the average walking time was greater than the average car time in that sample by 17 minutes because it was negative. Now if I look at a positive value, so in this case we have 12.6, then what I'm seeing here is a difference in the positive direction, meaning that the average car driver's time in this sample was 12.6 minutes greater than the average walking travel time. So now we can use this just like what we were doing before. We can estimate what's the actual distance in the population parameters based on our sample here. So essentially what we're trying to do is, from this sample, assuming it's representative of all high school North Carolina students' travel times, what we're going to then do is come up with an interval to estimate what the difference is in the typical travel time of a car rider or a walker. So we have 100 points on here now. Now remember, we are still using this idea of 95%, but now since we have 100 points, we can look at, essentially I want to contain 95 of these points in my interval, so I'm excluding the extreme 5 points. So first we need a center to center this interval around. So our center in this case is 3.4415. So we're just going to round this to basically 3 for the sake of what we're doing. So if we look at our distribution, clearly our minimum over here, we're going to exclude that. And then we basically want to trim another 4 points from each of these sides. So a good starting point for this would be, well, how far is it from my center to my maximum? Because these points on this side actually all look quite clustered together, so maybe it's just trimming this tail over here is what we're going to end up doing to get rid of those 5. So if we look at our max, we're going up here to 12.6. So if we're going from 3.4 to 12.6, and again, we're going to kind of hand wave here a little bit and round off a little bit. So if I'm going from what I said was about 3 up to basically 13, I'm going a distance of 10. Okay? So that could potentially be my margin of error. So let's look at what's 10 below 3. So if we go 10 below 3, we're down at -7. So we're down approximately here, which is going to shave off 1, 2, 3, about 4 of those points. So that would be a pretty good margin of error to use here to approximate, is that we're going to go about 10 minutes above and below the mean. So let's tie this all together and connect this back to the question that we had. The question we started with was, is there a significant difference between the travel time of walkers and of car riders of North Carolina students? And so if we look at this interval, what we're estimating is that that true difference in these population means is somewhere between -7 and 13 minutes. So let's think about that for a minute. If we are saying there's no difference, what value would represent no difference? So no difference in this case would be 0. There's 0 difference between these. If we think about our interval then, we notice 0 is pretty strong in the center of this interval. So it's very likely that we could get an outcome of no difference. So if we relate that back then, what we're basically saying is it doesn't seem like there is evidence to say that there's any difference in the typical travel time of walkers than of car riders, given the sampling distribution that we have. Now, let's say we want to actually look at this in terms of a difference that we're pretty sure is significant just from visualizing it, just so we can see what that interval would look like. So let's this time compare the typical travel time for the bus riders to the typical travel time of the car drivers. So we can still use this same difference of sample means over here, but what we need to do is we need to modify what we're finding a difference between. So in this case, instead of looking at the difference between car and walk, let's instead look at the difference between bus and car. And so all I need to do is change what we're taking the means of and reapply it. And so now what we're looking at is our differences in our means, taking our bus travel time means and then subtracting from that our car travel time means. And again, let's look at a graph of this, of our sampling distribution. And notice now what we were looking at to show no difference was that 0 would be in the interval. Notice 0 isn't even on the scale for this. If I look at the spread of all the differences in the sample means that I found, the lowest one I have is 37.98, so about 38. So what that's telling me is that this is clearly a significant difference, because 0 isn't even a possibility that we came up with in the difference of these sample means. And so when we start to look at these differences, when we're comparing two distinct populations, what we're looking for when we're coming up with our estimates is whether or not 0 is contained in that estimate. And this is looking at how can I compare the population parameter of a mean between two distinct populations, and our distinct populations being the different methods of travel that were used.